Hello, Professor. My name is Michael Cole, and this is my Artifact 4. The original intent for my Artifact 4 was to modify procedural mesh components and runtime mesh components for better use cases and more complex objects. It has been quite a learning experience, to say the least, and I've actually had to pivot a couple of times as I've learned more about their actual uses and how to do that. Um, I originally thought that runtime mesh components are just the end all be all most efficient object for everything, and why wouldn't anybody do everything with them? But it's come to my understanding that hand coding a procedural mesh component for all of its arrays, box vertices, normals, triangles, tangents, is something that is not done in the industry. Um, so I learned more about exporting objects created in Blender or Maya or even Unreal Engine as FBX files, and then re-importing them and using their information to generate that information uh, so that they can be integrated. But the use cases for runtime mesh components are usually for small objects that are generated at runtime and destroyed, or for map generation. So large landscapes, like used in Breath of the Wild and such, that can be randomly generated for um, each instance of the game, but not modified during runtime, and that's where procedural mesh components come in handy. So these can be modified during runtime. So in my experience, this last couple weeks, I've had some ideas and I've played around with, but I haven't been able to get to work. Um, how to generate those triangles to create a map using the Perlin noise in the math library to generate semi-random for a height map for the z component of each of the vertices in the triangle. So here's just some of the variables that I would like to use and the setup so that I can adjust them in blueprints as well. Generate all of it. So here's the Perlin noise. I'm using for loops for that. Based on the subdivision, some divisions can be adjusted just depending on the size of the map that you want to have. So probably bigger than that, but this is a good start. Um, and this part of the for loop, the next part, generates the actual triangles, I being the exponent, y being the j component as well, and then to pass all of those into the runtime mesh main array here using these variables. I haven't been able to get this to work yet, but I am working on it now and hope to have it either the end of this next week. Um, but what I did was something very related to that, working with procedural mesh components as well. So each of them have their place, and procedural mesh components can be adjusted at runtime. And that was something that also really fascinated me, so that I can create fantastically stylized objects and such in Unreal or in Blender or in Maya, and import them into the Unreal Engine, um, and then have the player interact with them during runtime. Like in so many video games where the character comes up to a tree and chops it down. So what's often used in those video games is just an interact function, so they overlap their within the space of the tree. They use the interaction key, whatever it is, to hack at it, and then the animation plays where the chunk comes out of the tree. But it's a pre-designed um, level or a vector on the tree trunk that happens every single time. You know, they line up and it happens in the same place at the same time because it's just calling that animation. What I wanted to do is create my own object, import it into Unreal, and then have the player actually interact with it from wherever they are. So if the player were to walk up to a massive tree trunk um, and chop at the world position and the forward vector that they're looking at, and chop at it, a chunk would come out right. The object would be distorted and modified at runtime right where they are. So that's what I've done here. So I've set up here, this is just the header function, of course, different procedural mesh component variables there. This is the CPP. Just changed the root component, attached it to the root component for the object mesh, generate it here, and then generate it as well, create the mesh section, set up the colors and such. And then this is the actual altering of the object during runtime. And what that looks like is, this is my tree trunk. I know it's not tree trunk-esque, but just to give an idea of size. So I also imported the donut that I made in Maya. This is also adjustable as well, but I'm still working with the blueprint on that one. So as the player walks up, they can, I'm using the key right now, I know you can't really hear it. They can interact and pull those polygons down. So here I am adjusting it at runtime. So if the player were to come up with an axe and hit their swing axe key, there you go, see? Changing the shape of the object at runtime by the player. And that can be done, based on wherever the player is. I can show you that. This is the call on the player's blueprint. Use the R key. Using the first person camera component, I get their world location, I get their forward vector, I multiply them, add it. There's the world location as start. Add those together, multiply them. That's the end. This is the break hit. Cast it to the object, and then alter the object. And that, the object itself, I can utilize this blueprint as well, which uses the code that I just showed you, to actually apply to any object that I create. So it sets it up, begin play. Here's the tangents, the material. Take the blueprint mesh, use the static mesh from the base mesh, create the section, set the vertices, set the triangles, set the UVs, a delay so the player can't just spam it as fast as they can hit the whatever key it is. This is the recalculating of the vertices, the triangles, and the UVs, setting that and updating that mesh section with all of its variables. So that's that. I hope you enjoyed my presentation. I feel like this is doesn't look fantastic, but it's something really fascinating. This is the runtime mesh component, by the way. This is the proc mesh that I've adjusted as well, but this is the one that's now modifiable. Thank you for watching, and have a great week.